Here we are going to discuss about the transraced coil ignition system. In automotive application, the transraced coil ignition system which provide a higher output voltage and use electronic triggering to maintain the required timing as fast, replacing the conventional ignition system. These systems are also called higher high electronic ignition system. A transistor interprets a relatively high current carrying circuit, that is, it controls high current in the collector circuit with lesser current in the base circuit. Therefore, the transistor used to assist the work of the contact breaker. Hence, this system is also known as transistor assist ignition system. The figure shows the circuit diagram of the transistor ignition system. The primary coil and secondary system, the distributor is there to evenly distribute all the spark plugs. It consists of battery, ignition switch, transistors, collectors, emitters, and resistor, contact breaker, ignition coil, distributor, and spark plug. The emitter of the transistor is connected to the ignition coil through the blast resistor. A collector is connected to the battery. The cam in the distributor is rotated by the engine. It opens and closes the contact breaker points. When the contact breakers are closed, the small current flows in the base circuit of the transistor. A large current flows in the emitter or collector circuit of the transistor and the primary winder of the ignition coil due to normal transistor action. A magnetic field is set up in the primary winding of the coil. When the contact breakers are open, the current flow in the basic circuit is stopped. The primary current and magnetic field in the coil collapse suddenly due to immediate riveting of the transistor to the non-conductive state. It produces the high voltage in the secondary circuit. This high voltage is directed to the respective spark plugs through the rotor of the distributor. This high voltage produces the spark when it is tried to jump on spark plug gap. It ignites the air fuel mixer in the cylinder. Next, we will go to discuss about the electronic ignition system. Figure shows the working principles of the electronic ignition systems. Batteries are ignition switch and primary ignition coil and secondary coil and electronic control unit, magnetic pickup, distributor, and spark plug. It consists of battery, ignition switch, electronic control unit, magnetic pickup, armature, ignition coil, distributor, and spark plugs. When the ignition switch is closed, that is, the switch is on, the reflector rotates, which makes the teeth of the electron closer to the permanent magnet. It reduces the air gap between the regulator and tooth and sensor coil, thus provides a path of the magnetic line from the magnet. The magnetic field is passed on the pickup every time when the regulator teeth passes the pickup the coil in which an electronic pulse is generated. The small current then triggers the electronic control unit, which stops the flow of battery current to the ignition coil. The magnetic field in the primary winding collapses. The high voltage is generated in the secondary winding. It leads to spark in the spark plug via distributor. The comparison between the conventional electronic ignition system. The conventional ignition system spark timing not depends upon the speed, but in the electronic ignition system, proper spark timing is achieved through the speed range. The moderate engine energy output from the ignition coil is obtained. High energy output from the ignition coil is obtained in electronic ignition system. In conventional system, noise occurs during the high speed, but in the electronic ignition system, it gives noiseless operation at high speed. Some carbon deposits occurs on the spark plug electrode in conventional, but in the electronic ignition system, remains clean of carbon deposits and ash deposits. More emission occurs in conventional ignition system, but electronic ignition system, the emission is reduced, but the increased output power. But in conventional system, less output